Hey everyone, in this video we are going to discuss about data types and variables. Let's start with the data types. We have a bunch of data types here. Data type is nothing but the type of data we store in memory. To make this even clearer, let me give you a real life example. Imagine you have a lunchbox and a water bottle here. Now, let's say you need to pack some food and water for your lunch. Now, to store food, would you use the lunchbox or the water bottle? Obviously, you would pick the lunchbox, right? Similarly, to store water, will you use the lunchbox or water bottle? Of course, this time you would go for the water bottle. Now, just like we choose the right container based on the type of item, in programming also, we need to choose the right data type based on type of data. I hope now you have a better understanding of data types. Let's go back and discuss various data types. When we talk about data types, we can break them down into two main categories. One is primitive, another one is non-primitive. Now, even with the primitive data types, we have two subcategories, numeric and non-numeric. Numeric data types are used to represent numbers. On the other hand, non-numeric data types are used to represent Boolean and character values. Let's dive into numeric data types first. Under this category, we have two types, integer and floating point. Integers are used to represent whole numbers. On the other hand, floating point is used to represent decimal numbers. Alright, let's start with an integer data types. Under integers, we actually have four specific types, byte, short, int and long. All of them are used to store whole numbers in different ranges as specified here. For example, if you want to store a value from -128 to +127, you can use the byte data type. However, if you want to store a value greater than 127, the byte data type will not work because the maximum value of byte is 127. In that case, you will need to choose the next data type, which is short. The short data type can store values from -32,768 to +32,767. If the value you want to store is greater than this, you will need to use the next data type int. The same principle applies to the long data type as well. Let me show you how it's done in programming. I am initializing a byte value here. Byte A equal to 100. As 100 fits in byte range, we are initializing with byte. Here, byte is a data type, A is a variable, and 100 is a value. You might be thinking, what is variable? Variable is nothing but an identifier used to identify any value. Let's say you are going to a school where we have 8 students in a classroom. Now, if you want to call any one of the students, how will you call them? Of course, you will call them by using their name, right? Here, name is an ID for the student. Similarly, in programming also, you need to have an identifier to represent or store any value. Then only you can refer them in other places. Now, coming back to the program, to store the value 100, I have created a variable called a, which can represent 100 in the program. Think of it like this. We have a box named a, and inside that box we are placing the value 100. Whenever we refer to a, the value 100 will be passed. Let's move on to the execution now. I want to print this byte value to the console. To print this byte value, I am using system.out.println. As I mentioned earlier, we can use the variable a to access the value stored in it. Let me run this program and show you the output. It's printing exactly what we wrote in the system.out.println statement, but that's not something what we have expected, right? We wanted it to print the value of a, which is 100. This is one of the common mistakes which we will make during the initial days. If we write A inside double quotes like this, you will notice that it prints the letter A instead of the value stored in the variable. This happens because anything inside double quotes in Java is considered as a string. So Java prints exactly what's inside the double quotes. Means if it is inside double quotes, it will print what we are giving inside double quotes. If we are giving without double quotes, it will print the value of the particular variable. To print the actual value of a, we need to refer the variable without the double quotes. By doing this, Java knows that it has to print the value stored in a, which is 100. Let me remove the double quotes and run it again. As you can see, 100 is printed on the console. As I mentioned earlier, the byte data type can store values from -128 to +127. We can use byte to store any value within this range. Let me change the value from 100 to 127 and rerun this program. You will see that 127 is printed to the console. Now, let's say we need to store the value 128. The byte data type will not work here because the maximum value of byte is 127. If we try to store 128 in a byte, it will result in an error. You can see the error here. To store 128, we need to move to the next data type short, which can store values from -32,768 to +32,767. Let me change the data type to short and you will see that the error is removed now. When I run the program, 128 is printed to the console. Let's try changing the value to 32,767 and rerun this program. It executed without any error because the last value of short is 32,767. But what happens when we are changing the value to 32,768? We will get an error obviously, right? Because the maximum value of short is 32,767. To resolve this error, we need to move to the next data type, which is int. When I change the data type to int, you can see that the error is resolved now. And I can rerun the program successfully. Now, we can see that the given number is printed to the console. The same principle applies to the long data type as well. I hope the concept of data type range is clear now. Let's move on to a different scenario. Let's say the value you want to store fits within any one of these ranges. By looking at this, you can easily select the appropriate data type. But what if the value fits within all four ranges? How will you choose one among these four types? For example, the number 100 fits within all four ranges, right? So, how will you decide which integer data type to use for 100? Let's make it simple with an example. Imagine you're choosing a container for milk. We have two containers here. One holds 1 liter and the other holds 2 liters. If you need to store 1 liter of milk, which container will you choose? Naturally, you would choose the 1 liter container, right? Similarly, if you need to store 2 liters of milk, which container will you pick now? Obviously, this time you would go for the 2 liter container, right? This is how we select the appropriate data type as well. Now, you may think like, why can't I just store the 1 liter of milk in the 2 liter container? Of course you can. But you would be wasting some extra space in that container that could be used for something else, right? Similarly, in programming, byte uses the least memory, followed by that short, int, and finally long, which uses more memory up to 8 bytes. Now, let's say I'm storing a value like 100. If I choose byte to store the value 100, it will work because 100 fits within the range of a byte. Instead of byte, if I choose short, int, or even long, that also will work without any issues. As we discussed earlier, byte uses 1 byte of memory, short uses 2 bytes, int uses 4 bytes, and long uses 8 bytes. If we know for sure that the value we are storing will always be 100, why do we have to waste extra memory? In this case, choosing byte is the most efficient option because it uses less memory. So, if memory is a priority and you are sure about the value range, opting for byte or short can save your memory space. On the other hand, if you are working with larger numbers or if you are unsure about the value range, it's more practical to go with int. I hope the concept of integer data types and their ranges are clear now. Let's move on to floating point data types. As I mentioned earlier, floating point data types are used to represent decimal values. We have two types under floating point data types, float and double. A float can store up to 6 to 7 decimal digits. A double can store up to 15 to 16 decimal digits. The float data type uses 4 bytes of memory, while the double data type uses 8 bytes of memory. As I mentioned for integer data types, the same logic applies to floating point data types as well. If memory efficiency is a priority and the value you want to store fits within the range of a float, you can use the float data type. Otherwise, for higher ranges, you should use the double data type. Let me show you how it's done in programming. Here, I have initialized a float with a value of 0.9234567. In Java, a float value must end with a letter F, so we append F at the end during the initialization. As I mentioned earlier, a float can store values up to 6 to 7 decimal digits. Let me run this and show you the output. You can see that the given value is printed in the console. Now, let me add more digits to the value and rerun the program. You will notice that the output is not accurate and it doesn't match with the exact value we provided. In this case, since we need to store more digits accurately, we will switch to a double data type. Let me rerun the program with the updated data type and you will see that the output is now accurate. So when you need to store values requiring higher precision, you should use a double data type. Otherwise, a float data type is sufficient for most of the cases. I hope now you got the better understanding of integer and floating point data types. If you have any other doubts, please let me know in comments. Okay, so far we have covered numeric data types. Let's move on to the non-numeric data types. Under non-numeric data types, we have two main types. One is Boolean, another one is character. Let's start with a Boolean data type. A Boolean data type is used to represent only two values. One is true, another one is false. This is particularly useful for making decisions in a programs. Let's move on to an example. Imagine we have a group of people here and we have to determine whether they are eligible to vote or not. To implement this in Java program, we are initializing a Boolean variable called eligible to vote. By default, we are setting its value to false because eligibility to vote depends upon the person's age. We also initialize an integer variable called age and setting value 17 to it. Next, we are adding a condition. If the age is greater than or equal to 18, then the person is eligible to vote, right? In that case, the Boolean variable eligible to vote will be updated to true. Finally, we print the value of eligible to vote to check whether the person is eligible to vote or not. Means if the age is greater than or equal to 18, it will enter into the if condition and the value will be updated to true. And the same will be printed on the console. Similarly, if the age is less than 18, it will not enter into the if condition and the value will remain false. Let me run the program and show you the output to make it clear. Here, the value of age is 17, so the if condition is false. In this case, it will not enter the if block and the default value of eligible to vote will remain the same. So the false value is getting printed to the console. Let me change the age value to 20. Now the if condition is true, so it enters the if block and the value of eligible to vote is updated to true from false. So when I print eligible to vote, the true value gets printed to the console. Now, let's say I don't want to print just true or false. Instead, I want to display a meaningful message based on the Boolean value. For example, in our program, if the Boolean value is true, it means the person is eligible to vote because their age is greater than or equal to 18. So, if the Boolean value is true, instead of printing true, we have to print you are eligible to vote. Otherwise, instead of false, we have to print you are not eligible to vote. Let's explore this further using an if-else condition. If-else statements help us to decide whether a specific block of code should be executed based on a given condition. If the condition is true, it executes block A. Otherwise, it executes block B. Now, I'll remove the existing system.out.println statement which prints a true or false. Instead, I'll write an if condition to print the meaningful message. If the Boolean value is true, we print you are eligible to vote. Otherwise, we print you are not eligible to vote. Now the value of age is 20 and the first if condition is true. So it will enter into the first if block and the value of Boolean variable will be updated to true. Now, coming to the second if condition, here the value of eligible to vote is true. So it will enter into the if block and it will print you are eligible to vote. Let me run the program and show you the output. It will print you are eligible to vote. Now, let me update the value of age to 17. So when it comes to first if condition, according to the age value, now the condition is false. So it will not enter into the if block and the value of Boolean variable will remain false. Now coming to the second if block, the condition is false. because the value of boolean variable eligible to vote is false. So it will skip the if block. As it is skipping the if block, it will enter into the else block and then it will print you are not eligible to vote. Let me rerun the program and show you the output. As you can see, whatever we have given in the else block gets printed on the console. To handle this kind of scenarios, we are using boolean data type. I hope now you are clear with the boolean data type as well. Now, let's move on to the next data type, char. A char is used to represent character values. It can be any character, but it can hold only one character, not more than that. For example, if you want to represent or store any student's grade like A, B or C, you can use char data type. I'll create char variable and assign value A to it. Notice that it must be surrounded by single quotes. For char data type, single quotes are mandatory. If we are writing without single quotes, we will get an error. Let's print this character value using system.out.println. I'll run and show you the output. You can see that the value A is printed on the console now. If we try to add one more character, it will not work. You can see the error here. As I mentioned earlier, char supports only one character. I hope now you are clear about non-numeric data types. So far we have discussed all primitive data types. Let's move on to non-primitive data types. Here we have string, array, class and all. Let me start with string. Using the string data type, we can store multiple characters. Generally, it is used to represent a collection of characters. Let me update the data type to string. And one more important thing is, when you are working with a string, you have to surround the value with the double quotes. If it is a character, we have to surround the value with the single quotes. If it is a string, we have to surround the value with the double quotes. In Java, anything enclosed in double quotes is considered as a string. Let me run the program and show you the output. As you can see, the value is printed to the console now. As I mentioned earlier, anything inside double quotes in Java is treated as a string. Even if you specify a number inside double quotes, it will still be considered as a string, not a number. Let me clarify this further. I'll remove everything and let's focus on a system.out.println statement. Let's write 1 plus 2 inside system.out.println and run the program. It prints 3 because the numbers are treated as integers. Now, let me add double quotes around 1 plus 2 and rerun the program. It prints the expression as it is because anything inside double quotes in Java is treated as a string. Let me do one more thing. We will add double quotes separately for 1 and 2 so you can clearly see the difference. Now take a closer look. We don't have the double quotes around the plus sign. That's very important here. Let me quickly run the code and show you what happens. It printed 1, 2. That's because 1 and 2 are inside double quotes, which means they are treated as strings. So instead of adding, it joins them together like text. Now let me remove the double quotes for 1 and 2 and rerun the program again. As we don't have the double quotes for 1 and 2, the numbers will be treated as integers. In that case, the plus sign performs actual addition and the result will be 3. So remember, if numbers are inside double quotes, they are treated as string data type and those will be concatenated. On the other hand, if numbers are written without quotes, they are treated as integers and those will be added. I hope now you are clear with the string data type as well. In the upcoming video, we will cover remaining non-primitive data types. If you have any other questions, feel free to ask in the comments. Thanks for watching.